Okay, so we'll finish up practice exam B. I think we only have a few problems to go over on that. And then I'll probably ask you guys if you have any questions to kind of start on after that. Might be a little bit shorter if you guys don't have a ton of additional questions, but we'll make sure we get through practice exam B. I've been posting, and I am by no means like a video editor, so these are very crude edits from my other sections. But if we go to, I'm gonna have to pause this. If we go here and look down here. So we went through a majority of questions on Tuesday. If you click on this video, in the description underneath it, it has like exactly what questions and kind of the order that we went in. And then the other two that I posted were basically the other questions from practice exam A other than like the first four. So there's not additional kind of mean or regular standard deviations on there, but every other problem on practice exam A, you can find in these two videos. So you have, me working through the majority of them. We saw a lot on Tuesday, but today we'll finish the rest from practice exam B, okay? So a little bit of information about the exam, because I have it up there. I don't think you can see it yet. When I get back after this class, you'll probably be able to see it, but I have it set to kind of 5 o'clock, be able when you can get on and take it if you want to take it today. Once again, it's open to the end of the day on Sunday. It is 17 questions, so multiple choice. Each one's worth 4 points. And then there's 2 short answer that have kind of multiple parts. I think the one is A through D and the other is A through C, okay? Those 2 short answer total are worth 32 points, making it a 100-point exam, right? So, 30%, a little bit more than 30% come from those short answers. So when you're working through those multiple choice, keep that in mind. There's kind of still about 6 or 7 questions there you have in the short answer. Now, some of those questions in the short answer are relatively easy and shouldn't take very long. But you do want to make sure you kind of save yourself enough time to kind of get through those, okay? And upload kind of whatever work, however you're going to upload your work for those, whether that's Word, Excel, or just kind of taking pictures or scanning what you do, okay? And don't worry, like even if you're just doing it from your phone, I've never had anything that's not, I can't convert at the very least, right, to something I can view. So I've never had issues with that. There's also a bonus question on there, so just to kind of clear it up. It looks like another multiple choice question. It's the very last one, but basically there's it's worth another 4 points. So it's bonus in the sense that if you get it wrong, it doesn't count against you. And then if you get it right, it adds an additional 4 points. So you can kind of think about when you see your total score, it's going to look like the exam initially until it's over is worth 104 points. It's not. It's just the way that I have to set it up on Canvas originally. Once everyone takes it, I'll kind of download it and re-upload as a new assignment, like a new quiz or new exam, so that it will only be graded out of 100. So you could technically get whatever 104 out of 100 is on the exam. So you get above 100% if you get every single point on it, okay? But that basically you can miss one of the multiple choice and you could still get 100. Any questions related to the exam before we kind of jump into some review today? Oh, good. I should have mentioned. That's one thing I didn't mention. It'll be 1 hour and 20 minutes, right? So a little bit longer than if we took it in class. I don't think time should be a big issue. Like I said, some of those problems on the short answer, like some of the parts of it should be like relatively quick and easy, not a lot of computation. So I think that the time shouldn't be a huge issue. Yeah. Any other questions? Because that's a good one. I meant to mention that. Yeah.
So you just need to make sure to upload the pictures within that hour and time?
Yeah. And so, once you have your work done, for those 2 last ones, we'll have like file upload options. You just upload those files. If something comes in where it shouldn't take that long for those to upload. I mean, it should take not a lot of time at all. So yeah, part of that hour and 20 minutes is getting those uploaded. Like I said, I wouldn't plan on scanning them or anything, so that takes a while. So just a picture and uploading that work, or uploading your Word or Excel files. Okay? And if you're uploading a Word or Excel file, make sure you save it and then upload it. Like you're not kind of having it having it open, trying to upload because maybe it didn't save your most recent work. So save it first when you're completely done and then upload it. Oh, one more question. No, I didn't. There's no quizzes this week, right? Because we're just doing review. So there are no quizzes this week. We're just doing review. And then we have kind of this exam. Right? Any other questions? These are good questions. So. Okay. All right. So the one thing I said I was definitely going to start today off with, or on practice exam B, is problem 11. Okay. So let's say, I don't know, we've got some major concerns of steroid use in baseball in the past decade. A manufacturer claims, we could read this whole thing out, but let's just first start out identifying what we're given here, okay? What I want to switch my video over. So this might take 1 second. There we go. I'll blow this up. I'll make this the whole screen in just a second, but so the first thing we're told is the probability a drug test shows a positive result given that the athlete is using steroids is 0.95. So let's just start writing out what we know here. So the probability that given someone is using or uses steroids, the probability that the test shows a positive result, or you could kind of say that they are using, right? We're told that's 0.95. Okay? So one approach to this, and you may not always need to find these kind of complementary probabilities, but remember sometimes we said there's going to be pieces of information that we're not given that are missing, but we can determine what they are, right? So I'm going to leave a little space here, but we'll kind of identify the other two things. Then I'll come back and say what I would do if I was working through this from the beginning. So the next thing we're told is the probability it shows a positive result, given that the athlete is not using. So we've got given that they're not using, the probability that the test shows a positive result is what? 0.01. And then the final thing we're told is the probability that if we selected a player at random, the probability that they're I guess I'm going to change this real quick because this doesn't, we'll call this using, because that's what I'm going to be saying. I just know the way that I talk. So the probability that someone's using steroids there is 0.15. Okay. So those are the three things that we were given from this information. Okay. So one thing that we could do is anytime I'm given a probability, there's a complementary probability I could find. The easiest one to think about is if I know that the probability someone is using a steroid is 0.15, what's the probability that they're not using? Yeah, just 0.85, right? The two states of nature have to add up to 1. This is almost kind of like hidden behind there's like the complement rule, right? There's only two states of nature, so if this is event A, this has to be a complement, right? If I'm using is event A, I'm not using is the complement. Right? So we know those two things have to add up to 1, so we can figure out that one pretty easily. Now we may not need these probabilities for the questions asked in this practice exam, but there could be questions asked where I might need some probabilities I wasn't directly given. So this was the idea that after let's assume that we start out, and I just wrote down that first thing I was given. Okay? After I write that down, what might be a good practice, just so you have all the probabilities you could ever need, is that if we condition on the same state of nature, but look at the other outcome of the test, right? Well, given that someone's using, they either get a positive test result or they get a negative, right? It either shows that they're using or they're not, okay? So if we're conditioning on the same thing, the probability of the two outcomes of the test have to add up to 1. Right? There's only two possible things I can see on the test. Any example I give like this, like we're not doing anything where there's like an inconclusive test. Okay? So if this is 0.95, I know that this probability has to be Yeah, 0.05, right? Pretty easy. Then we can do the same thing here, right? If we're going to kind of maybe keep these separate, I'll draw a line here, draw a line here. So once again, after I wrote this probability down, what I could have done is say, okay, well, look, I'm going to condition on the same thing that the person's not using, but look at the probability of the other outcome of the test, which would be that we see a negative test result. And if it helps to write out the word like positive and negative here, that's fine. I'm just kind of shorthanding. So we're conditioning on the same thing now. So someone who's not using, if the probability they get a positive test result is 0.01, what's the probability they see a negative test result? Right? Two outcomes of the test, we're conditioning on the same state of nature, or think about it as we're looking at like the same individual. Those have to add up to 1 as well. Okay? Move this over here. Any questions on that? We haven't even got to the problem yet, but I'm just kind of, anything you could ever need to do on these next couple problems on an exam, this would give you all the information you could ever need. Okay? So let's go. Leave that up here down in the corner. Let's think about the very first thing that we're asked to find. So, got all these together, and then we're asked, what's the probability an athlete uses steroids and tests positive? Right? So we're going to go here, write out what we're looking for. Okay, so what's the probability that they're using, and the test comes back positive. Okay. So we're looking for the intersection of these two events. If we go to our formula sheet, scroll up here, we've got that the intersection of two events is simply the conditional probability times what I'm conditioning on. So I'm just going to write out this general equation in the context of my example, right? So here we can think about is my A, here's my event B, okay? So the intersection should be equal to the probability of B given A, so the probability that the test comes back positive, given that they're using, and then multiply by the probability of A, or the probability of what I'm conditioning on here, right? Notice the probability of what I'm conditioning on is A, so the probability that they're using. Well, once I write this out in the context of my example, I go back here, what's the probability that, given that they're using, that it comes back positive? Well, that was told to me just to be 0.95. And then what's the probability that they're using? We had that down here, was 0.15. Okay. Any questions on that? I know I kind of like put this back because I can't have this all on the same screen. So we just grab those from those earlier probabilities and plug those in, right? Easy as that. So we're going to get what? 0.0 or 0.8 something. No, 0.143. I'm thinking of the next one. So we get 0.143, and we're done, right? So, this question was a little bit easier once we kind of wrote everything out in the context of our example. Okay. Any questions on that one? You want to see something again, or? Is anybody else having problems on Zoom seeing me, the video? Okay. Try leaving and coming back in and see if that fixes it. Or maybe this will help, just kind of showing you should be what's up on the video. Okay. Any other questions on that? Okay. Okay, awesome. Glad that worked. All right, so now we'll go to the next problem, which was, and kind of do the same sort of thing. I'll leave this up here so as I'm writing, you can kind of see. What's the probability an athlete is using steroids and test positive? Okay. So now what we're looking for is, what's the probability that someone is, what did I say? I actually might have said it wrong. What's the probability they're not using, and this test comes back positive. Right? So just writing out what the problem is asking for. Okay? Well, it's the exact same thing we were doing before, right? We can think about this as my event A, this is my event B, right? And it's going to be using that same rule where we can look at the conditional probability times what we're conditioning on. Okay? So now, just as a reminder, that highlighted formula is the one we're using. So A and B, right, is the probability of B given A. So the probability of the test coming back positive, given that there, right, our event A is not using. So we just, right, I'm really just writing out this equation I have highlighted in gray in the context of my example. Okay? And then I kind of didn't leave myself a lot of room here, so I apologize, but multiplied by the probability of A, well, my A here, or what I'm conditioning on, is that they're not using. Okay? So just wrote out this equation in the context of my example. I'll make this a little bit bigger so we can kind of see that now. Okay. Any questions on that so far? Yeah. Oh.
We're not seeing like when you go to the equation and we're not seeing.
Oh, sorry. Hold on. Should have said something. Let me go back so I can show you.
Why does it not?
You're good. You're good. So in class, you weren't able to see it. Let's see if this works. There we go. All right. So what I was doing there, here was the general form of the equation, right? The intersection of A and B, right? Which I just wrote down kind of what the problem stated. The probability someone's not using and they test positive. So once we have that probability written down, we go to our equation sheet. We've identified what RA and RB events are. So then I'm just writing it out, right? The probability of B given A, there's a general form of the equation. I'm writing it out in the context of my example. Then multiply by the probability of what I'm conditioning on, or my event A here, which I have over there. Okay? Yeah.
So what's the best way to determine what A and B?
I mean, I'm usually pretty kind, but right, it doesn't really matter what we call these, right? The general form of the equation is calling them events A and B. And so I can just think about whatever's in this first category, right? When I'm asked for that probability, it said, what's the probability someone's not using and the test comes back positive? So I just wrote that down. I'll call whatever's in the first position A and whatever's in the second position B. It's as easy as that. You know? Right? They're just whatever our, whatever the example we're looking at is, kind of substitute in the names there. Is that cleared up? Okay.
Thank you.
Any other questions up to that point? And at this point, once we have it written down, we just go back. Okay, what's the probability that someone's not using, given that they're not using? Probably the test comes back positive. Well, given that they're not using, probably the test comes back positive we had was 0.01. And then what's the probability they're not using? We look here, oh, it's all the way down here. Probably they're not using was 0.85, right? So we plug in the 0.85 there, which is going back to what we originally had and kind of plugging those probabilities in. And this is the one that should be what? 0.0085. Actually, sorry, 0.0085. And then if we round that, I think that the answers were rounded to the third decimal, if I'm recalling correctly. Yeah. All right, so we go down here. We had to round to that third decimal, so 0.0085 becomes 0.009. And then the one that we found previously was that 0.13. Okay. Any questions on that? So those two weren't terrible, right? I'd say the next one's a little bit more difficult, probably one of the more difficult questions on the exam. Okay. Let's knock something off. I'm going to need that, so that's a little pain. Come back. So We'll scroll down here, go to question 13. And it always starts out, let's write out what we're looking for, okay? So given that the test comes back positive, what's the probability the athlete is not using or does not use? So here, we've got a conditional probability. So given that the test comes back positive, what's the probability that they're not using? Okay, that's what we're looking for. Right? So the problem here is going to become, if I go to my formula sheet, okay, I have a conditional probability equation here, but that's going to be really just this is being rearranged. So if I want to find the conditional, it's the intersection divided by what I'm conditioning on. Well, the problem is, what am I conditioning on here? That the test comes back positive? If I go back to my original equations, I don't have just the probability that the test comes back positive, right? All I have are conditional probabilities of the test coming back positive. So the probability the test comes back positive is going to be composed of two groups: people who were using and it correctly identified as using, and people who weren't using and had this false positive, right? So I don't have just the probability of my event B, the probability that it just comes back positive without any other information. So, you know, these practice exams are written in a similar way to the exam, and it's probably a good point once you get to this point that if I'm looking for a conditional probability and I'm only given other conditional probabilities, I'm probably going to have to use this Bayes equation, right? And that was the scenario we had in this case. We were looking for a conditional probability, and the information that we were given, we only had information on kind of these conditional probabilities for the outcome of the test. So all I'm going to do, and I wish I could make what I'm writing a little bit bigger, because I do want to have kind of this pulled up, this general form, so that you can kind of see me work through this, right? So I'm going to take this general form of the equation. Think about this is my S, and this is my event E. Okay? So I see a lot of you kind of have laps, so hopefully you can have the formula sheet of E. If you want to have it pulled up, I'm going to make this bigger so it's a little bit easier for me to see. But I'm basically just going to talk through this equation, right, and write it out in the context of our example. So the very first part of that Bayes equation is the probability of E given S, right? So the probability of E, the test comes back positive, given S, our S was that they were not using. And then it was multiplied by the probability of S, so the probability that they're not using, right? And that's what's in our numerator. So hopefully this doesn't screw us up too much in class here. But basically what I was doing there, okay, now we can see it. I just wrote out that numerator, oh, sorry, I wrote it out of order. I guess the probability of S should have been at the beginning, but it doesn't matter, right, what order we multiply things in. All I was doing was writing out this numerator in the context of my example. Now notice, the first part of the denominator here is the same as my numerator. So for the sake of just, when I'm writing this down, it's going to be the same thing. For the sake of just having enough room, I'm just going to say that, you know, this is the same thing as what we have in the numerator. If you want to write it all out, if you have enough room on, you know, kind of your notepad there, you would write out exactly what we have in the numerator as the first part of that denominator. And they're always going to be the same there, right? The form of the general form of the equation, those will always be the same, okay? So the second part is the probability of S complement, right? So if our S was that they're not using, what would S complement be? They are using, right? So S complement is that they are using. And then it was times the probability of E given S complement. Well, our E was that the test comes back positive. Our S complement, we just said, was that they were using. Okay? So once I have that Bayes theorem written out in the context of my example, it makes things a lot easier, because now it's just a matter of going back and plugging things in. Right? So what's the probability that they're not using here? Well, we had that earlier was 0.85. So we can kind of think about 0.85. Given that they're not using, what's the probability the test comes back positive? We're given that information, right? Given that they're not using, the probability the test comes back positive is 0.01. Now, the first part of that denominator is the same as the numerator, so I don't really have to keep going back. I know that it's just going to be the exact same thing there. Okay. Now, what's the probability that they're using? Oops, sorry. Okay. So what's the probability that they're using? I go back. Well, probably they're using was 0.15. So plus 0.15 times. Given that they're not using, what's the probability the test comes back positive? Given that they're using, the probability the test comes back positive is 0.95. And now it should be kind of, right, that's a little bit easy. Now I just enter that into my calculator. Okay. Any questions on any kind of part of that process? So anytime we're looking for this conditional probability, write it out, what you're looking for. Identify what your S and your E are. That way, you can kind of use that formula sheet equation to help you write it out in the context of your example. Once you have it written out in the context of your example, then it's just a matter of going back at those original probabilities and plugging in those values. Okay? Any questions on that? Okay, so this is probably one of the harder kind of questions on the exam. And you will see one like this. Okay? So what does this end up being? This, I should have my calculator pulled out here. I might have forgotten in my office, but I think it ends up being what? This group is going to be larger. So if we go back here and look at the possible answers, if I recall, I think this is this one 0.056, I think? Yeah, if we work out that math, we enter that into our calculator. Okay. So if we compute this, it ends up being 0.056, okay? Any other questions on that one? Okay. So I wrote the exam. So those of you, how many do we have here? Yeah, we got 15 people on Zoom and about, what, 10 people here. So for those of you who showed up or end up kind of watching this will help you. These next two things, I would highly really review, okay? So it's not on any of the practice exams, but when I think about correlation coefficients, right, we talked about these in class one day. If I were to say that, I don't know, something like the relationship between income and we'll do education is a stronger relationship than between test scores and hours of, oh, what's this goofy? Hold on. I'll get that out of the way. And hours of, I don't know, Netflix watched. Okay. So know that the relationship between education and income is stronger than the relationship between test scores and hours of Netflix watch. I also know that you kind of think about, I might even add in there, the relationship between income and education I'm kind of shorthanding here, is positive, and test scores and hours of Netflix is negative, right? So maybe that's kind of the information that we're given, right? Maybe it's written out a little bit more, lengthy than this. But what that's going to tell us is something about our correlation coefficients between these different, right, sets of variables. So I'm going to write my correlation coefficient between income and education. and my correlation coefficient between test scores and Netflix. Right? I might write those words out, but kind of using the first letter of each one just to abbreviate there. So with that given information, what do I know has to be true about the correlation coefficient between income and education? Well, first of all, I'm told it's positive, right? And I know that the correlation coefficient, if the relationship between these two things is kind of inverse, or there's a negative relationship, this one has to be negative. If I know that the relationship is stronger between income and education, does anyone recall, if we're looking at the correlation coefficient, what range does that have to be in between? Yeah, right? That was the idea of turning the covariance into this like unitless measure so we could compare across different types of variables. So we know that it has to be, if it's a stronger positive relationship, then if, let's say if this was 0.8, what's the range of possible values for the correlation coefficient between test scores and Netflix, hours of Netflix watched? So if they were exactly the same strength of relationship, they'd be the same value, but just different signs, right? But here we said the relationship between education and income is stronger than the relationship between test scores and the hours of Netflix watched. So I know this has to be something closer to 0, right? Less than 0.8. So this is good, could be something like negative 0.6. It could be negative 0.3, right? So just with this information, I can think about what are possible correlation coefficients I could see. Now, if you had possible answers like in a multiple choice where I said, you know, this correlation coefficient is 1.2, doesn't make any sense, right? I can't ever see that. Or if I gave you like possible correlation coefficients here, which were, let's do 0.3 and negative 0.7, why couldn't those be the correlation coefficients given this information? Because what would this mean? Yeah, this would indicate that the relationship between test scores and hours of Netflix watch is stronger, right? And that's not what we were told. We were told the reverse, right? So kind of with this information, you can think about what would be possible correlation coefficients or correlation coefficients that would line up with the information you were told. Okay? So it might be something to kind of review or go back in the slides and then kind of review that correlation coefficient, what we talked about. Yep.
I don't understand the 0.3 and just, I understand everything else, just what you said about why would
okay.
be stronger.
I should have crossed this out, right? Yeah, so anytime, so the correlation coefficient ranges from -1 to 1.
Mm-hmm.
1 is the strongest positive relationship we could ever see. -1 is the strongest negative relationship we could ever see, right? So the closer this gets to -1, the stronger this relationship is. So what this would be telling us is Netflix or test scores and the hours Netflix watch, there's a stronger negative relationship between those two things than the positive relationship that exists between income and education. So I guess if we're following along here, I would say that's not an answer. I would cross that answer off if I'm doing that. Okay. Any other questions on that? Like I said, I know there's no correlation coefficient kind of or covariance stuff on the practice exams, but that would be kind of have a good understanding of correlation coefficients and that idea that closer to 1 is a stronger positive relationship, closer to -1 is a stronger negative relationship. We're okay with that? Let me double check. As I said, I didn't see the chat flash on me, but we're good with that? All right, the other thing I did want to review, and I'll leave this up in case someone's still writing, but let's go back to the exam so I have something to work off of. Let's go back to the contingency table that we looked at on Tuesday. Okay. So we had this setup where we had this contingency table and we were asked a bunch of questions on it. One of the questions that we didn't go over, but that you could be asked is, okay. Actually, can I make this any bigger? I thought I made it as big as possible, but I feel like it's still, I should write Zoom. So I'm telling you, I should probably send someone an email. It'd be pretty crazy if they added that feature. But what if instead I was asked for not an intersection or a conditional probability, but let's say I was asked for the probability that, I don't know, someone doesn't want marijuana legalized, or, right, looking for the union there, or they're kind of a Republican. So if that's what if that's what I wanted to find, we didn't cover that, but if we go to our formula sheet and go up here, remember we said the union of two events is simply the probability of each event added together. But then we had to subtract whatever was in both, right? So we didn't double count it, right? We counted it twice, so if we subtracted out once, we only counted it once. So here I'm looking for the union. I could rewrite this as the probability of that first event plus the probability of that second event, but then subtract, right, the intersection. I ran out of room here. Right, I think I wrote too big, right? Let's go here. So once I have that written out in the context of my example, right, probability of each event here added together, but then subtracting the intersection of those two things, right? So instead of the union here, we've got the intersection. But if that's what I want, that's pretty easy to find from the table, right? So if we go back here, what's the probability that somebody doesn't want marijuana legalized? Well, go to LM equals no, 0.45. What's the probability someone's a Republican? So yes, Republican, we go down to the total column, that's 0.5. And then what's the intersection of not wanting marijuana legalized and being a Republican? Well, remember that was one of those top 4 left cells where those two things kind of would intersect there. So 0.35. Okay. From there, it's just some simple math, right? We get what, 0.95 minus 0.35, so this should be 0.6. So this is a good one. Actually, it's not a good one, but I'll give you an example of another good one. If you forgot to subtract the intersection here, we would have had 0.95, right? Or if you had instead added it, right? If I forgot and I accidentally added this, I would have ended up with what? 1.3. But why would I know I made a mistake if I added this up and found 1.3? It's probability. It has to be between 0 and 1. Right? So, you know, if we think about kind of errors we could make, maybe adding the intersection right, even though we should have been subtracting it. Or if you just forget to do it altogether, that one's kind of tough because if we forgot to subtract the intersection here, we still get a result that could make sense, 0.95, right? So it's really important when you're looking for these unions, you remember that you subtract that intersection, okay? So that could be another question, wink, wink, that I would ask is how to find the union using a contingency table. Okay? Any other questions on that one? So that should give you pretty good setup for the exam. The other thing I would really review is what we did on Tuesday when we talked about the Poisson distribution and changing time intervals. Right, so I would go back and if you want to rewatch that or look at your notes, have a pretty good handle on being able to take an average rate, right, and going to a different time interval. There's like one connect question that's like that. We also did some in class. Or no, sorry, we didn't do any. That was on Tuesday's class that we kind of covered that at the beginning of the class. So if you go to that video after my little talk about the exam and things, the first thing we do is kind of converting those time intervals. Okay. Any other like specific questions for me, maybe on practice exam A, or kind of something that you know, maybe I can come up with an example that you're just, I'm having trouble with these, or, yeah.
The same one you just mentioned, the Poisson. I was
Okay.
asked a question about the connect assignment.
Okay.
Just like the conversion of it.
Yeah, so the one in the connect is definitely more difficult than anything I'd ask you on the exam, right? Because I think the time intervals there is like, you know, you're thinking about hours, and then like an hour and 30 minutes or an hour and 44 minutes or something. So yeah, if you're going to do something like that, we're thinking about how to convert kind of some goofy ones. Like I said, on the exam, I'm going to do something like hours to minutes, so you'll know that you know, would divide by 60 there. But let's think about, I have got an average rate, we'll do for an hour, of, I don't know, let's make the math easy here, 10. Okay. What if I then said, again, what's the probability I see 20 successes in an hour, 30 minutes? Right. Well, first of all, one of the things we talked about Tuesday is if I'm going to a longer time interval, am I going to need to multiply or divide? Multiply. The easiest way to think about this is if I'm going from a day to a week, you know, if on average I see 10 a day, how many would I see in a week? Oh, 70, right? I would multiply by that 7, right? So I know I'm going to have to multiply here because I'm going to a longer time interval. Forgot to get rid of this. There we go. But exactly what do I multiply? Well, the numbers here are a little bit easier. You can probably think about, well, you know, I'm going to multiply by its 50% increase, so 1.5. But how would I get that 1.5? Well, here, you know, it's kind of goofy with time, because really when I say an hour, what I'm saying is 60 minutes. What's my new interval? Kind of 90 minutes. So what I'm really doing there is kind of taking the ratio of my new interval over my old interval to get kind of that factor I should be multiplying by. Like I said, in the exam, I'll keep it easier where it's like I'm going from a week or a day to a week. I know I multiply by 7, right? The factor is always going to be easier there because the original one would be like 1, right? But here, I would take 90 over 60. That's 1.5. So if I'm trying to convert, so I've got that 1.5. I'm trying to convert and find my average for an hour and 30 minutes. Okay. This is just going to be the original times that factor of 1.5, which would give me 15, right? Which kind of makes sense here, right? If there's 10 every hour, an hour and 30 minutes, there should be 15. Now I have my new lambda, I've got my x, it'd just be a matter of kind of plugging those values in. So what was it? Lambda to the x, e to the negative lambda over x factorial. Okay. Any questions on that one? And then kind of the reverse, if I was going from to a smaller time interval, right? Instead of take, my new interval, this is still how I'd find my ratio. So let's say instead of an hour and 30 minutes, I wanted to go to 30 minutes. Well, then it would just be 30 over 60, right? And that would be kind of my new factor. Right? But, for the exam, I'll keep it easy where we're going, really our original interval is always going to be 1. So I'll always be dividing by 1. It makes that idea a little bit easier, right? Going from 1 day to a week, well, 7 over 1, I multiply by 7, right? Or going from a minute to an hour, well, 60 over 1, right? All my factors I multiply by 60, right? So I keep it a little bit easier like that. But that connect, yeah, like I said, sometimes the connect homework questions are going to be a little bit more difficult than what I would expect on the exam because you have more time, you can ask questions. Any questions on that one, or the idea, or do you have any other questions that you want to see me work through?
I forgot to ask this earlier, but how you said like uploading work.
Yeah.
Is the last 2 like short answers? Are those the only questions you have to do partial credit, or are you saying?
Yeah, just the short answer. Yep. So those are the only 2 that I'll grade kind of for partial credit. And I won't have those. Well, I doubt I'll have those done by class Tuesday. There's a small chance that I might be able to get them done, but we got a lot of you, and it kind of depends, and really depends on how well you guys do. If you guys do really well, it's really easy to grade. All right, so.
So for like the Connect homework, problem I always come into is I don't know which formula I'm supposed to use.
Okay.
So is there like an easier way to figure out which one to use?
So in terms of these probability mass functions, or just like in general?
Your formula sheet and like going through the problems on Connect.
So if we go to that formula sheet, right? One thing that can help is if you just had this formula sheet, I think I mentioned this Tuesday, writing next to it which each formula represents, right? Because when you're asked for questions, I mean, part of it is understanding the concepts, right? So if I see, for example, if I see a bunch of different outcomes and I see that they all have probabilities of occurring, well, then if I'm asked for a mean, I can't just simply add the numbers up and divide by the number of numbers I have, but I have to know that it's because the outcomes aren't all equally as likely anymore. They have associated probabilities. So from there, then I know, okay, I don't use my original mean equation, right? I should be using, or I've got probabilities associated with seeing each value for X, so I should be using this discrete random variable. Or if I have different kind of values for that X variable, but there's some type of like frequency associated with them, so I've got weights, right? That's the idea of, where is it? Right here, like we got a weighted mean, right? So in terms of identifying the formulas, part of that is just really understanding the concept. There's no like roadmap, right? Certain keywords will give it away, right? Like if I say like, the different outcome, or I shouldn't say keywords, but key parts of the problem. Like if I see probabilities associated with those different outcomes for X, then I know that I've got this discrete random variable where I'm trying to kind of predict what the outcome is going to be. Or down here, the difference between when we know we need to use this probability mass function for the binomial or the Poisson, well, that was the idea. We said, well, if I have a cap number, like I'm looking for the number of successes out of 20 or out of 30, that tells me I should be using the binomial. If I'm looking for the number of successes over an interval or a time over the next hour, over the next week, over the next month, that's when I should be thinking about using the Poisson. So part of knowing which functions to use is kind of understanding even just with the setup of the problem. So I understand why it's difficult, but there's not really like an easy answer as to when to use which ones. But I do think it helps if you write out or print out this formula sheet or type in Word or however you want to do this. Actually, you probably could do like text boxes next to this Word document too if you just want to do it all on your computer. But putting what this is the binomial, probability mass function, and here's my covariance, and here is my weighted variance. And then it just makes it a little bit easier to navigate. And then if I see like a keyword like weighted, weighted mean, weighted variance, you can kind of connect to the formulas a little bit easier if you have those words next to them.
What would be the best way to figure out all the names? Because I don't know all of them.
So, like I said Tuesday, as we're working, some of these aren't going to necessarily have names. I guess this one is like the multiplication rule, but that doesn't necessarily help you apply it anymore. What would help probably more is this is how I find a conditional probability, right? If you're not sure on some of them, you could reach out to me and ask, as we're kind of trying to work through this. A lot of them, as we've been working through these examples, I've tried to say like, I even know like Tuesday for sure, like I would say like, here's our binomial distribution functions, right? Here's how we find the mean, right? Mu is the mean. So if you're kind of starting from scratch and you if you're going back through, you should be able to find most of these in the slides as well. But if you're filling this out and you run into somewhere you just don't know what to call it, reach out to me and I can help you out. I'm not going to probably sit down and go through the entire thing line by line with you, but if you get stuck on some and you reach out, I'll give you kind of point you in the right direction to kind of let you know what those should be. I know it's not like sometimes it's not the answer you want, but that's kind of the answer for that. So. Yep. Any other questions? You want to see some specific problems worked through, or just sort of doing it? Might end a little bit early here because, like I said, this was kind of like I said, we'll work through the rest of practice exam B, and then if there's, I'll leave it open for questions. If we don't have any, kind of stop there. But, you know, anything I did today or Tuesday, you know, I know we worked through a lot of practice exam problems, but sometimes as we were working through those, I said, what if this changed? Or you know, I kind of went a little off script. There were probably reasons why I did that. Right, today when I brought up the correlation coefficients, I brought up knowing how, and I'm glad like you asked, like how we do these time conversions with the Poisson. I brought those up because I wrote the exam, right? Finding the union, right? So anything that we kind of went through or kind of I mentioned this week, Tuesday, Thursday, you know, I would pay attention to those things and really make sure you have a good understanding of those. Okay? Now, the practice exams are a very good indicator of what the exam is going to look like, with the exception of those short answer questions. That being said, some of the multiple choice questions I really just converted into a short answer question. So those would be kind of my primary source for what I would make sure that if I'm studying, I want to make sure I go through those and understand those well. Right? Yeah.
Should we expect any of those like Excel type equations?
So these exams have no questions asked about Excel, right? Purely the kind of, nothing that we saw in Excel, yeah.
So if we prefer to use the functions in Excel, can we use those instead of doing the hard math?
Yeah, you can do that. That's why one of the options for those short answer.
So like you're not going to be mad if I give you an Excel sheet just full of like equals binomial or equals Poisson.
If those are the short answer questions, let's say the binomial question or short answer is a binomial question. Yeah. If you use those, that's fine. Right? Now, what I would caution is make sure you have a good understanding of how to use those, right? Because the Excel is great, right? This is like one of the things, hopefully you leave this class and you realize like Excel can make my life a lot easier. But Excel also black boxes a lot of things, like in the sense that you can't see what's going on behind the scenes. So if you use the function wrong, it'll still give you an answer sometimes, but that answer might be wildly incorrect, right? Let's say for the binomial, I flip-flopped my probability of, I don't know, flip-flop my number of trials and my number of successes. Well, then, all bets are off, right? But if you feel comfortable using Excel, if that's how you want to do the short answer work, hell, if that's how you want to do some of the work for the other problems, right? I'm not giving partial credit for that, but Excel's there for a tool. That's actually one of the main reasons why I don't use these lockdown browsers, because then I can't have that as an option. And that to me is, once you go to your job, they're not going to tell you can't use Excel to calculate. So they're actually going to tell you probably need to use Excel to calculate something. I'll go on a little bit of a rant because I had a meeting with a couple students this week and some alumni. We were trying to get some internships and jobs. And, one of the things that they asked, what's a blind spot that students don't think they need? And I was like, I think it's like this, understanding of Excel. And every single one of the alumni or that have, who are have positions and pretty high up in corporations all said, yeah, this is like, anytime we see this on a resume, anytime someone has any understanding how to use it, like this is a huge benefit. This should be a selling point of yourself. So they're going to expect you to use it. So why would I not let you use it, right? So sorry, that was probably a longer answer than was required. But any other questions? Okay. Make sure double check in the chat. I didn't see it flashing at us. All right. Well, if you want to reach out today, I've got a couple meetings set up with people that reached out already. Tomorrow, I teach from 12 to 2, but if you send me an email or want to try to kind of schedule something late morning or kind of right after I get done teaching there, probably between 2 and 3, I could do some last minute meetings there if you have some questions. I'll try to look at my email over the next 2 days and get some responses out, but I can't, guarantee that if you email me on Friday, if you're taking the exam at 11 o'clock at night, that I'm going to get you an email response right away, okay? But I will be taking a look periodically at my email throughout the weekend, okay? All right. Well, good luck, and I'll see you guys on Tuesday.